Yes, it works. Somebody was joking about Ulrich being old, and I was about to start that I started my career as a developer somewhere in a weird office in Ghent in the Onderstraat.
Yes, and who was joking that I was old? I'm not old.
Which means that was 26 years ago?
I think so, like this. Hopeless, thank you to remind me about that.
So yeah, I used to be a developer.
I think I still have some pictures of that, you know?
Do you still have pictures of the reference?
I think so.
This?
Yeah.
That would be cool.
Ponytails all over the place.
Yeah, and people with no driving licenses for cars.
That too.
All kidding aside, that actually was my second job. But I started ages ago as a developer, with things like Perl, PHP, bit of C, a bunch of Java, and then I eventually became the guy who knew how to rack a machine in the data center. And then I knew how to spin up virtual machines and how to scale virtual machines. And that was somewhere when we started calling this thing the cloud. So I became an operations person. Today, my role is basically CTO. You can fill in what the T stands for. It could be trolling, could be travel, could be technical. Basically, the lead engineer at Inuits. For the people who weren't here this morning, Inuits is one of the larger open source consultancies in Europe. Belgium, Czech Republic, Ukraine together, somewhere just around 100 people, a bit above. What we do for the past 15 years is we've been helping people to deliver software with open source tools. And that ranges from lots of stuff which we build downstairs for the Port of Antwerp, IoT platforms, track and trace for the Police of Antwerp, but also large-scale cloud platforms, public government, private companies. Pretty much, if it's open source, we probably touched it. Since March, I guess, we started a new spin-off, which is called Ollie. And Ollie is really focusing on open source observability. What we basically want to do there is help people who are adopting these technologies to help them doing that the right way with open source tools. Frederick has already been hinting a bit at my background, but about 2009, we had a cloud camp here in Antwerp, and Elisabeth Salem, we had this really crazy idea, Patrick Dubois and I, to bring together like 60 to 70 of our closest friends. That's how we started a small conference in Ghent, which is called DevOps Days. The name actually came from John Alspaugh, who gave a talk at Velocity that summer called DevOps 10 deploys a day at Flickr. So that's how we got the name. Since then, people are doing things like building DevOps teams and becoming DevOps engineers. So that's one of the things I started, but also together with Toshan, we run config management camp and load days whenever we find a new venue for load days, and then probably move the building. So yeah. So I basically started all of the above. It started with 15 years ago. Most people know me from my blog, which is titled "Everything's a Fucking DNS Problem." You probably know that. And you can find me on most of the social media, Twitter, GitHub, Mastodon, whatever. So that is basically my background. I used to have a ponytail when I was at the reference, then I went to no hair, and since the pandemic, I have long hair again. I'm not the only one in the room. So defining cloud. I think that's already the first challenge. 10 years ago, when we were talking about cloud, it was pretty much those 4 keywords we were looking at. It had to be on demand, like I need compute power now, I spin it up, and I kill it when I don't need it anymore. It had to be API driven in a way. Lots of people said it had to be pay as you go, which kind of removed all the private clouds. And it should be able to scale left and right. And I think Frederick said somewhere 2010 you started with AWS. I know somewhere before that we were discussing different open source cloud technologies, ranging from eucalyptus, things that eventually became OpenStack, and everything around. I really need to think hard, but I think I co-edited the book on Zen somewhere 2009 or 2007, I guess 2007. And basically the cloud was built on Zen. Amazon first couple of years, they were built on Zen virtualization technologies. But since then, a lot of things changed because we basically said the cloud is just other people's computers. But now, if people ask you, what is a cloud now? Well, most of them actually say, well, it's all of the above, but it's also a container platform. And lots of people are now talking about cloud basically being Kubernetes. I'm not sure if I agree with that, but if you look at mainstream media, that is what we talk about. And I say any container platform because there's obviously more. So how do you fall or fail into the cloud, and where's the difference? I think stepping back to me is like talking about why we started DevOps, how we started DevOps. And for me, the definition of DevOps is basically it's a global movement to improve the quality of software delivery, leveraging an open source experience, which we started again in 2009. And it still is body. I used those slides together with Patrick, I think in DevOps 2011, and it's not easy. Working together, doing things, it's definitely not easy. And if you look at where we started, I think over lunch we had Mary Poppendiek mentioned, we talked about Agile, we talked about Frederick was pointing to books written by people who were at the roots of the Agile movement. But the DevOps movement was started at the intersection of people who had a large background in open source development and actually running open source stacks in production, people who were doing things in an Agile way, who were looking at how do you differ Agile from purely development to also doing these in operations, but also people who were basically doing their first experiments with cloud technology. And back then it was either things like OpenQRM, Eucalyptus, or, well, there was Amazon, and not much more. So based on open source, based on doing these things, we needed to learn how to work together. I really like to get to the point where this kind of approach is history, the wall of confusion. But in a lot of organizations, it is still the norm. On the left side, what we see is there's developers, they're being paid to build features, to build functionality, to basically build value for users. And then on the other side of the wall, there's operations people, and they need to run things. They need to keep them up and running. They need to keep them stable. They need to keep them secure. And sometimes that is people who are in the same team. Sometimes that's people who are actually the same individual. And we've had all that level of confusion. 15 years ago, it was two different teams, two isolated groups. They didn't talk. And as a movement, we started trying to figure out, like, how do you go from a developer saying, hey, it works on my machine, it's an ops problem now. How do you go to that smooth journey where you have the ecosystem, where you have the tooling, continuous delivery, continuous deployment, continuous integration, to get things from something that works on somebody's machine, one local machine, to building that and deploying that at cloud scale. And we started doing things like infrastructure as code, working together on building platforms. Platform as a service is not something which is new. Platform team is basically a new name of things we've been doing for ages. But we started collaborating and working together with people with different interests, with different point of views. And then basically trying to solve this. Please ship my laptop to the data center because This doesn't work. Building vagrant boxes didn't work. Well, it works, but people were nagging about it. So we started doing things like containers. Docker started happening. I have graphs on how my kernel panics evolved over the years. You can see when Docker got introduced. Stability was not its nicest thing. And then people said, hey, the enterprise is going to do container adoption. Frederick pointed to banks. This is what some people have implemented as being an enterprise container. We went from image sprawl, virtual machine management, to containers. And I've seen this in the wild way too many times. So basically, what is this? This is a full operating system where people have full databases running in. They have middleware in there, some application, they have backup agents, they have monitoring agents. And this is what they basically treat as we're going to the cloud. I hope you're not doing this. If you're doing this, you're in trouble. So that's one side of the spectrum. On the other side, what we've reached now is Ultimate Cloud, where every random developer basically builds an image, does something in there, and then throws it over the wall to the operations people who now have to run this. They might throw it to Frederick. I hope not. But what have we done over the past 10 years? We've run in a circle. I mean, I see a bunch of people who are older than me here. They realize people run in a circle, we don't solve problems. But this is effectively what we've done. Frederick taking pictures. So the thing is, when it works in your developer's container, that's only a really, really, really small part of the challenge. We went from infrastructure as code, building reproducible infrastructure, scaling things out, doing that in both private and public clouds, to somebody who wrote something which works on his machine again, and he throws it over the wall, and then the learning curve starts. Because Michael Duchy tweeted this 2016. One application locally, and then on the other side, getting it into production, which basically means it might not be Docker as an engine anymore. You need some orchestration, you need some networking, you need figuring out how to do rolling upgrades, you need to do monitoring, you need to do configuration changes, you need to do service discovery, you need to do hosting of things, you need to do code quality, you need to do security, and lots of people basically, well, they never reach into production. They don't have the time, they don't have the energy, they don't have the skills to do this. There's a really huge gap between it works on my machine, it works in my container, to actually getting things to production. And then we got Kubernetes, and Kubernetes was going to solve all of the problems. And basically, this is how most people get started with Kube. I mean, yes, I'm one of those people who were early days looking at the stack, trying to deploy it, trying to run it. And it really is like there's the easy hello world thing, but once you start thinking about how do I do CI on this? How do I do multiple namespaces? How do I do networking on this? How do I do security on this? It's this chaos. And people look at it like it's a huge field of options. I'm sorry, but to me, this is a disaster. Looking just at the observability part here, the corner down here, do you want tunnels or do you want Cortex or do you want Mimir or do you want one? Which one do you want? Every option in that ecosystem has 25 different flavors. If you start in this is your maze. You need to figure out where to go. You need to figure out what do I need, what fits for me, which choices do I need to make? And the walls of confusion we saw between dev and operations before, now this is even more chaos. Like when Luca was asking who can actually describe a bunch of these, nobody can, nobody wants to. There's a bunch of people out there who actually are building distributions out of this, who make opinionated distributions of Kubernetes, like Rancher, like Red Hat. So what you end up having, the distributions, can you count them? That's 5 times, and this is an old CNCF slide. That's 50 something more distributions of people who have opinions on how to run this standardized ecosystem. So yeah, finding your way in this ecosystem is not something I advise you do. Not my clicker, it's the operating system underneath. Or the lack of operating system, whatever you choose. So we were helping people to deliver software faster, better. And yeah, sometimes you think this container thing, apart from the kernel panics when you touch storage, might be a good thing. And what we noticed is that over the first couple of years, we saw people starting to play with tools and never stuck with their first stack. Frederick mentioned people try to build things on-prem, move to something in the cloud. We've seen people shift from OpenShift to Rancher, from Amazon to OpenShift, from basically OpenShift to Plan 9, from Google to building it themselves again with Kubespray. We've seen all flavors. And we've seen people do this 2 times or 3 times, to the point where like, okay, so what are you actually trying to do? Are you trying to deploy an application and run an application, or are you really just trying to play with containers and figuring out how the ecosystem works? What we also saw is that some of the cloud vendors and some of the distros, like if you deploy things on OpenShift, it's not going to be as trivial to deploy it on Amazon because they're opinionated. And some of the features, because a couple of weeks ago in Barcelona, some people were ranting to me about the Amazon implementations of namespaces was actually not the way vanilla Kube does it. So they couldn't just even port traditional standard namespaces. So if you think you're talking to a standard platform, which is portable, which you can move from left to right, and where you can just deploy things, for some level, yes, that might be true. But once you start deciding on using a different CNI, you're using a different CSI, so that's network interfaces, storage interfaces. When things start to become really opinionated, this is not about I can deploy it on one cluster and it's going to be reusable on another one. Frederick mentioned people stick with one cloud. Never had the discussion about can I migrate out of a cloud? I have multiple use cases in our customer base where people actually were forced to move to a different cloud provider. If you're doing scraping shops and suddenly one of those large shops you're scraping says, we're going to block all of the Amazon IPs, you need to be able to deploy somewhere else quickly or you're out of business. I heard somebody saying this morning they need to do business with China in the Middle East. Amazon, not really there. You might need to be able to deploy in Alibaba or on other clouds. And I know there's other people with cases like that. Yes, for a lot of people, Amazon has a good workload, but it is definitely a vendor lock-in. And deploying on their Kube ecosystems might not be the answer you're looking for. Same with Kube. So what we've done over the last couple of years was basically look into what is a cloud agnostic platform? What is something that we can deploy faster without having, we build our own Kube stacks. We ran those for a while. And I think the last one, I tweeted about it, the last one we decommissioned was not 2-3 months ago. And we were happy to be rid of it. We looked for alternatives. We looked for open source alternatives because we only do open source. And we ended up with Nomad. We ended up with Nomad as a container orchestrator, which is much more easy to deploy. It's basically one single binary. That single binary you can deploy anywhere. It is really cloud agnostic. It's also cloud aware because it has the concept of availability zone. It has the concept of multiple data centers. And it seamlessly integrates with HashiStack. And HashiStack, we mean things like Vault, Terraform, Console, and all the things, which a lot of you are also already using in the Cube ecosystem. So that is one part of our journey. Like, don't stare blindly at Cube. Look at the other things out there. For people who are vested in Cube, it's definitely not something bad. It's something really good. It's a really good API. But it is a journey about starting to ask the right questions. And a lot of the questions I'm going to ask in the next couple of slides is questions we see people forgetting to ask. And it is about, is this application the right fit for containerization in general? And containerization, not only containerization, but even just basic cloud adoption. And basic cloud adoption, I mean, we've seen this happen since EC2 started to become popular, when people said, hey, I need multiple applications, multiple deployments of the same thing. Containers, still the same problem, high availability, scalability. Biggest part of the problem is, where is your state? Where is my data hosted? And if you're building a new application, you can start from scratch. You can actually start looking at remote object storage, putting things in databases, and making sure that there's no state locally, so that if something crashes, doesn't matter, you respin something new, whether that's a VM or a container on a public cloud, doesn't really matter. But if you take the traditional monolith, which you've been building for the past 15 years, there's going to be state in there, which is going to be local, which is going to write to a file system, which is going to make sure that you cannot deploy this in a public cloud or in container without a lot of pain. And I would love to be able to say what Frederick says, like, the customers we work with have a roadmap and want to move that monolith out and want to slice it. But sadly, I've seen a lot of those promises, but not a lot of action. But that might be the kind of customers we've been dealing with. So there's a lot of ecosystem where there's a large amount of state into locations where you don't really want those. We talked a bit about microservices this morning and this afternoon. The whole monolith versus microservices thing is basically a pendulum which is constantly swinging. I think that heat and the top Microsoft moment is about 3-4 years behind us. That's when we saw already things swinging back and people started realizing it's not about microservices, but it's about services, and you need to figure out which size fits for you. And sometimes that is a big part. But what Frederick definitely pointed out correctly, it is about the team size. If you have 2 persons running 500 microservices, that's not right. But a team should be basically owning at max 1 or 2 services, which they can control. So in a way, Conway's law is really important there. But the clean APIs are definitely important. And with APIs, we're looking at, can you do forward and backwards compatibility? Can you do upgrade? Can you have multiple instances of that application running together? Most organizations are still failing there. And then the other thing is it scalable? And for startups and scale-ups, sometimes that is important. But for the larger part of our industry, if you have a corporate environment and your customer base works from 9 to 5, scalability is not going to be a use case. So maybe that container ecosystem is not something you look for. Most people have predictable workloads. Most people have stable things. We're not all running live ticketing sales. Those have valid use cases. A lot of us still have monolithic applications. And if that is there is nothing wrong with deploying them continuous delivery style, automated, but not in a containerized ecosystem. It's actually much better. One of the things we've also experienced is that complex network thingies also don't containerize that well. If you're doing things like streaming, if you're doing things like security, VPNs, TCP is pretty trivial. Once you go into UDP, might be our set of interns, but we had 2 years ago, we asked a bunch of interns, can you put things like Jitsi and Big Blue Button, can you put them in a containerized ecosystem? They failed completely. Might be because the interns, but we also have, for example, we run a bunch of devices where we do management of the edge devices. We use OpenCloudification to do the management of the edge devices. Trying to get OpenCloudification to run onto Cube on Nomad. It's not fun. Basically because of the way how they deal with networking and how they set up open VPN connections to the end devices. You want that to be pretty static and not constantly moving around. So not all of the workloads on the world do fit for containerized ecosystems. If they fit, a few architectures, yes, please. What we also seen is that people said, hey, containers are going to help us doing CI/CD. And with CI/CD, I mean continuous integration, continuous deployment. Continuous delivery is something not a lot of organizations achieve because most of them don't have the budget to do the sufficient test coverage to get there. But my return question to them typically is like, why aren't you doing this already? Why haven't you automated things already? What is blocking you from doing so? Why do you think the cloud is actually going to help you doing that? And most frequently, the answer you get is, I need to have ephemeral environments which I can spin up for every single branch. And the answer to that is you're not doing CI/CD, you're doing continuous isolating. You basically are not doing what the basics of continuous integration say, which is trunk-based development. If you need multiple long-running environments, you forget about software architecture feature flags, you forget about really doing continuous integration. You need to fix another problem. And most organizations really don't need those deployment strategies. They don't have the use case to do dark launches, to do all of those things. If you have them, yes, please do so. But do you have them? Who's doing dark launches of applications? Who's doing actual A/B testing, feature flagging? Okay, let me check. Who's awake? Okay, those are hands. Because last week I was speaking in Germany, and when you do who's awake, they don't even react. You need to actually ask, are you a human? And then they might. So really ask these questions. If you've been answering no to pretty much every single question I had so far, maybe you don't go to do things in containers. If you can basically say, my application is stateless, I don't care when it crashes, and I can have multiple instances next to it. It has no state. It's typically going to be short-lived because I'm going to be constantly upgrading it and refreshing it. I can crash it and it's going to be up and running again. Yeah, sure, please, but make sure it fits. And if your application state is on a disk or a remote file system, if it's in a database remote, okay. If it's in an object store, yes. And NFS, which is what a lot of people who are now spinning up Cube ecosystems in corporate environments, NFS is not a solution. NFS is a problem we tried to fix in the early 2000s. So yeah, if your application state is really a problem, you're doing heavy I/O, might not be the right use case. Can your application run multiple times? And multiple times means, first of all, state, but also can you have different versions next to each other? Is your API backwards compatible? Because you might be deploying something and looking at how different container ecosystems do the orchestration, how they do rolling upgrades. How does your database deal with having multiple versions next to each other? Can your application still talk to the older version of the application schema, or does it really need that version? And how do you know if an application is ready to actually serve traffic? These are things you need to put in that architecture. You need to look at your application. Taking that one big monolith and just putting it in a container It's not going to be able to run multiple times. It's not going to be able to have multiple database schemas. And it's definitely going to take a long while before it starts up and says, hey, I'm healthy, if it even figures out how to say it's healthy. So given that you have a use case, given that you have applications that are in need of velocity, in need of flexibility, you need to start thinking about how do they talk to each other? And how do you encrypt traffic between them? How do they find each other? You need some kind of service discovery. And DNS is not a service discovery mechanism. How do you encrypt traffic? And does your team understand how to do encryption? Does it need to understand? I remember one of my former team members didn't understand the basics of a Zell, but he was going to work for a crypto startup. Most people do not understand encryption, sadly. So there's tools out there that solve this. And that's basically why we have service meshes, to clean up the mess your architecture creates. Because this is what your network architecture is going to look like. And you won't manage that automatically. So which service mesh are you going to choose? More security. I mean, we had the corporate ecosystem on the right where we're going to pre-build you an image and you're going to use that image and it's going to be 2022 and it's going to be RHEL 6. And we're going to run all these agents in there, all the proprietary agents, which are actually backdoors, which are going to ship data offsite to somewhere you don't know. Maybe, I don't know, I don't see the source code. Or the other side of the spectrum, I mean, on the right side, we have full control, we know what's there. Fine. But on the left side, we really reached a new level of problems. If I look at our infrastructure, about 700-800 nodes, probably more right now. If there's a CVE, if there's a vulnerability, our assessment to figure out in a pure VM ecosystem how long it's going to take to figure out if you're vulnerable for something, it's somewhere between 5 and 10 minutes, because we know what's running. When every random developer you have can start a container and can start building on top of something somebody built and then build on top of that, you really need to think about your supply chain. You really need to think about figuring out where is this coming from? How is this built? Can I reproduce this? Much, much, much harder at scale. Because works on my machine now became a security nightmare. In most cube stacks we've seen, I cannot identify what is running there trivially. Yes, I can, but it's going to take much more effort than in another ecosystem. Unless you actually start working upfront together with your developers, you put out a bunch of patterns, you put out a bunch of rules, you agree on working together and you collaborate. Which is not what happens when you take a monolith and shove it into a container. So these are all things that we really, really need to look into. We mentioned a bit already, don't get locked in. I call it being cloud naive versus cloud native. Yes, I have managers who basically come to me, oh, I have Terraform. I can just do Terraform apply against Azure today and tomorrow against Google, right? No, that's not how it works. You need to rewrite a bunch of things. Where is your customer base? Is it really Amazon focused, European, American targets, or do you really need to scale globally? And then there's the thing we already mentioned. It's not because you're developing against one cube stack that everything you do there is going to work on another. So moving from one cloud vendor to another, or even doing upgrades, typically means just redeploy, rebuild your pipelines and do things. So for some people, lock-in is a strategic choice where they say, we're going to go all in Amazon. We know what the problem is. We know what our limitations are. We also see the benefits. fine. For others, not so much. Frederick has seen different use cases than I have. But there's other things that have changed. Containerization and clouds is one hype. Last 2-3 years, we've seen a new hype, which is observability. To figure out what that is about is basically also, again, taking a step back, figuring out what's monitoring. Monitoring is basically checking what is still running. We're going to have a high-level overview of what's running on your infrastructure. We're going to have checks on what is available, mostly focus on the technical components. We're going to look at performance, things like this. We're going to basically monitor and look at what's going on. And monitoring is answering the question, what is going on in our ecosystem? Problem with a lot of people doing traditional monitoring is that they forget to automate it. So we get alert fatigue, we get things that drift from reality, and the root cause really is complete lack of automation. People manually configuring things, and proprietary tools are definitely the ones which you cannot automate. You get stacks that are absolutely not in sync with reality, where people basically think like, I'm been red for 3 days. Yeah, just gonna ignore this. Oh, there's another alert, and that looks like the same, but just gonna ignore this. It's a lot of work to maintain these things unless you do it correctly. If you really automate it, it can be fine. But a lot of people forget to do that effort. Now, add to the fact that we went from 20 years ago, one physical server in the data center to today, a couple of hundred physical servers in somebody else's data center, running different virtual machines on top, and then running containers on top of that. That's a totally different scale. And it's also a much more dynamic scale. The server or the container that was running 5 minutes ago, in 10 minutes, it's not going to be there anymore. That workload might have completely shifted somewhere. Whether that's a VM or a virtual machine, doesn't matter. Those things move around today. And we also, at that point, don't care anymore about, I have 4 nodes now, and there's one which is misbehaving, as opposed to I have 400 nodes now, and there's one that's misbehaving. The one that's misbehaving, we're going to treat that differently. We're going to treat that as cattle. When we have 4 nodes, it's going to be pets. It's going to be, oh, what's going on? Why are you not working correctly? You have 400, I just kill it. It's going to respawn somewhere, it's going to be different. So our monitoring needs, in a way, they're still the same, but they have changed. We're now much more monitoring is the service we're delivering, if that's still a good thing, as opposed to the server, which we're monitoring. So we need new tools there. Next time I present from my own laptop, then I don't have this.
I think it's just the infrared.
It could be. Or it could be the fact that there's a USB hub in there, which actually delays.
That could also be the case.
So the new thing basically is observability. And with observability, the difference is that we start not looking at what is still on, what is running. We start actually looking at understanding how our services behave. Like, look at the applications from within their place, not from some external observer, but from how is this thing behaving? Why is this going on? As opposed to what is going on. And you actually have to try to do that without writing incident-specific code. You can go into your code base and say, hey, log this and send this output. That's what we've been doing for ages, but kind of want to do that without writing that code. And that is where we basically connect monitoring and observability and say, well, monitoring you need to do. You have to have that in place. And if you're lucky, monitoring is more than enough. But Julien Vivoto, who's the permission maintainer, he actually says observability is removing the lock. It's going from, I know why this is happening, I know how this is behaving. If we look at observability, the current joke is there's 4 pillars, and people are inventing additional pillars, but let's stick with 3 pillars. The three pillars are basically metrics. There's a really old dashboard that you're looking at. How is my application behaving? How much memory is it using? How much requests do we have? How much failure rates do we have? All of those things we're monitoring based on metrics. Then we have logs. What are your applications doing? What are they outputting? We're shipping all those logs centrally. And really weird. And then there's traces. And traces is basically the idea that you can basically take an HTTP call and figure out what that completely does all the way down to the database and see where's the latency, where's the delay, and which action triggers what in your ecosystem. When you're doing microservices, this becomes something which is really important to know, because sometimes you just get lost. So who already has all of this? We already have traces, metrics, monitoring, all of it. Alex and Frederick, okay. I have a lot of people who basically, we evolved this for ages. We started doing metrics with early Graphite, even before that RRD tool, Ganglia, and those kind of things. We started doing log shipping. Well, the moment Jordan started Logstash, we started doing traces ages ago. But most teams, I bet you probably also have. Do you still know how long your metrics you keep them? Prashant knows how long he keeps his metrics.
2 years.
2 years. You've not moved to Prometheus yet, or you changed retention by default. We see a lot of people who basically, they've had Graphite, they've got something, and now they switch to Prometheus and they actually forget the retention. And 30 days later, their data is gone, because that's the default. So they don't have the long-term metrics anymore. And if you look at new stacks, even if they spin up container ecosystems, they forget that the container needs to ship and send data to standard out, and that you need to ship that. So we see people who used to have all of their logs somewhere centrally. And now they don't. They forgot about a bunch of the logs they have. Do you have dashboards? I'm pretty sure that a bunch of the dashboards you have are broken. That I know from our experience, at least 3 times over the past 10 years, my SQL dashboards were broken. Because we started using different metrics, we started using different tools, and the things we were wanting to look at had moved to a different location. And when you need them, you don't have them anymore, even though you think they are there. So I'm pretty sure that if you move to another ecosystem, you're going to need to fix all of these. So look, I already predicted I was going to talk about Prometheus. I want to throw in Prometheus in a way because it really is one of those tools that is helping you with cloud deployments, with monitoring. It is one of the graduated CNCF projects. It's originally pull-based. You can do push, but it's more difficult. It's really tying into a lot of the service discovery tools, whether it's be console, whether it's be just kubestacks to public cloud providers. There's so many tools that it is building into, and you can basically say, hey, here's my data source, monitor these things based on tags, and you can also do alerting on there. And it kind of has become the de facto standard for monitoring containerized workloads. Obviously, open source standard. There's a huge ecosystem of exporters. Like a lot of applications basically have exporters for Prometheus that you put as a companion, as a sidecar, or whatever next to Prometheus, and it's going to export metrics for that specific application. It's a real distributed open source ecosystem. It's maintained by multiple people. Head maintainers, junior people to work for us. What is new in Prometheus, for those who might not know, since June, July, there's actually a long-term support version of Prometheus. So one of the things with CNCF ecosystem is that every 3 to 6 months, that image goes bigger and bigger. And the release pace of a bunch of the tools is way too fast for most organizations to keep up. Permission kind of has the same problem. It's going so fast in innovation that people were basically asking like, oh, can we get some versions which only get security patches, which are going to be released at a slower pace? Actually, that is what we're building. It's still an open source upstream project, but it's mostly us who does the work there. If you are moving to a containerized or a cloud platform, one of the things you really need to do is expose those metrics. Like your application needs to have an endpoint / metrics where it's exposing metrics in a standardized text-based format. Yes, there's discussion about protocol and whatever, but the text-based format is the standard. And you also want to probably have some health endpoints that already are used from container orchestrators to figure out that the applications are healthy. You probably want to use those through the backwards exported and monitor those also. But this is where a bunch of people who just do lift and shift completely fail, because they don't have metrics exposed. They don't actually have the health points that they're checking. And it's also sometimes where a bunch of developers get confused because they expect that things are magically gonna be monitored and magically gonna work. So no, there's still some effort to be done that people need to write code for, or use the libraries and include libraries in there. So don't forget those. So I've seen a lot of horror and failed cloud adoptions, and up to a point where if you're not architecting for containers, please don't do it. But it really is about asking the right questions, like, is this the right fit for you? And if it is, it's a really awesome ecosystem. But if it isn't, it's going to be really painful. So do your homework before you can jump into this. And choose Cube, choose Nomad, choose whatever you want, but know why you choose it. And know that you asked yourself all of these questions before you do make that step, because otherwise it's not going to be a success story, it's going to be a failure. And I don't want that to happen. That was the last slide. Questions? No clue how we're doing it.
It's okay.
7 minutes left.
No. 7 minutes over, but that's okay.
Okay, 7 minutes over. Whatever. Questions? Yeah.
In one of your slides, you were giving an example of people moving to Plan 9.
Yeah.
I was wondering who wanted to move to Plan 9 and why.
I can't disclose the company, not in public. But why? Because they weren't happy with OpenShift. And they were not happy with OpenShift. All of it. Most organizations, what I see, and I think Frederick was really right into that, don't run this yourself. Use somebody who does this, public cloud provider, whatever. Use a third party. I mean, we run managed Nomad for people. Frederick does managed Cube for people. There's a bunch of people who know how to run these platforms, who can help you on board, who can help you guide to this. But what we see a lot of people who say, hey, mostly banks even and public government will say, hey, we're going to build this ourselves. We can do this. Yes, but you already have X thousand nodes to manage. You're going to need an identical team with the same skill set, basically doubling your effort, doubling your cost. And because those people are going to make all of the mistakes that I just listed, it's going to be a painful journey. So then they blame the tool. It's OpenShift. It probably wasn't OpenShift. It probably was the fact that they didn't listen to the network engineers. It probably was the fact that they didn't re-architect. And they might not have been really happy with what OpenShift was doing for them. But the answer was not move to Plan 9. The answer was take a step back and answer those questions first, and then maybe move, and not put the monolith into a container and run it. And it's not just one I've seen fail there. I actually think I need to check, but I think they abandoned the plant mine platform also now. And now we're really running into a break.
Any other questions, comments? Thank you very much, sir. Great.